this is Britt Caswell with another example video. In this example, I am covering lesson 1-2 in the Savvas Realize Algebra 2 textbook. This is example number 2. And so this example involves solving a linear system of equations using matrices. That's the plural form of matrix, if you've heard me talk about that in class. And so we are taking a system of equations. Usually we use matrices for systems of 3 equations. You can do it with systems of 2 though. But we are taking this system of equations and we are writing it as an array of values. I like to think about it as like a diet form of a system. Because instead of having all the x's and y's and equal signs, I'm just paring it down to the numbers that I'm dealing with. So the way that we do it is we put it inside these square brackets, very nice large square brackets. And I'm going to have a row for each equation. So I have 3 equations, I will have 3 rows going across. And then I will have a column for each part of the equation. So all of my x's will go in the first column. Everything for the y values goes in the second column. Everything for the z values goes in the third, and then the constant values go in the fourth. And all I'm going to do is write the coefficients for each number in my matrix. Now remember, a coefficient is the number in front of the variable. So if I have an x here, remember there's an imaginary 1 here. So my coefficient for that x is a 1. The same thing for my y. There's an imaginary 1 here, so my coefficient is 1. And then I have 2z, and then I have the number 13. So now I have put my first equation into my matrix. Now the second equation is a little different. If you notice, it doesn't have an x value. So if a variable is missing, I am going to put a 0 into my matrix. And what that does is that fills in any holes that I would have in my matrix. So then in the y column, I have a 2. And in the z column, I have a 1. And then in my constant column, I have a 5. Then for my third row, my x column has a 2. My y column, if you notice, my y is being subtracted. So when I go to write my 1 in here, I'm going to call it a negative 1 for the y. And then again, I'm missing a variable. I'm missing z, so I'll put a 0 into my matrix. And then my solution is 6. Now it is worth noting here that some programs put a bar right here in their matrix. This bar represents the equal sign. The program we're using does not, so I'm going to erase the bar. But if you're using a different calculator than I am, sometimes you might see a line there, and that's okay. So now a little bit of history here. There is a mathematician. His name is Carl Friedrich Gauss. He's a German mathematician, and arguably one of the best mathematicians in history. And he's my favorite mathematician, just so you guys know. So what Gauss said was that when you have a matrix, there's different types of operations you can do with it. Okay, I'm not going to go in depth with the operations in this video, but I will find example videos for you guys. But you could do different things, just like you could do with these equations, right? I could add 2 of the equations together, so I could add 2 of these rows together and produce a different row. Or I can multiply an entire row by a number, just like I could multiply both sides of an equation by a number. Or I could write these in a different order if I want to, right? I could put the third equation before the first equation, right? Which would make sense. You can write equations in whatever order you want. So what Gauss did was he developed this kind of procedure in order to write the matrix in what's called the reduced row echelon form. I'll say that again 3 times fast. Reduced row echelon form. We call that the RREF. And what the reduced row echelon form looks like is this. Okay, here's your matrix. Got those brackets. In the part where the coefficients are for the variables, you have this pattern. It's all zeros with ones going across the diagonal. And then you'll have numbers out here. I'm going to call them A, B, or C. Those could be anything. Those are the answers. And so that reduced row echelon form is actually telling us the solutions. Do you see how the X column only has a number here? So this is saying when you have one X and no Y's and no Z's, the value is A. Or when you have one Y but no X's or Z's, your value is B. And when you have one Z with no X's or Y's, your value is C. So this reduced row echelon form gives us the opportunity to write our answer as an ordered triplet. That is, it's a place in space. So you guys are used to seeing a coordinate plane like this, right? With an x-axis and a y-axis. This is now taking it into the three-dimensional space. Okay? This is called the z-axis. And while I'm drawing it on paper, it's hard to see. But this goes out of the page. Okay, so this z-axis is approaching you, the viewer of the video. And so what we're doing now is we're describing these lines in three-dimensional space. So this is where we're starting to get into math that allows us to model a lot of real-world situations. For example, ballistics, when people shoot bullets, or architecture uses stuff like this a lot. We use this a lot in business as well for determining minimums and maximums, but that's a whole other story. Alright, so we have our matrix, and we want to write it out in reduced row echelon form. So what I need to do is I need to use some kind of calculator, because we don't know the operations yet, to help us to do that. And so the calculator we're going to use in this class, at least, is the Desmos Calculator. And I'm using the website desmos.com/matrix. Alright, this is a special calculator just specifically for solving matrices. So what I'm going to do is I'm going to take this matrix and plug it into Desmos. So if you see there's a new matrix button, so I'm going to hit new matrix. And this matrix is too small right now. It's only a 2 by 2. But I need 4 columns for this problem. So if I click on the plus next to columns, it'll add the extra columns. I also need 3 rows, so I'm going to add another row. And I'm just going to type in these values exactly how I see them. Now it's important to note that to move quickly through the numbers, you can hit the tab key on your keyboard. A lot of calculators, if you're using like a TI calculator, you could just hit the equals and it scoots you through as well. So there's my matrix. Make sure to double check that you didn't miss any negatives or that you typed it in properly. Now it still has me editing, so I'm just going to click outside of the matrix, and it's going to give me this part down here. For the purposes of Algebra 2, you do not need the majority of these. You just want this RREF button. So when you click that, it's asking what it wants you to find the RREF of. Because I could have multiple matrices just preloaded in here. So I'm going to type the letter A. And just like that, my reduced row echelon form is spit out in the computer. Now remember, the reduced row echelon form is not the solution. The solution is an ordered triplet. It's a point in space. So I'm going to be taking this 3, 0, and 5 back to my problem, change back to blue, and I'm going to write it as an ordered triplet. 3, 0, 5. Okay, this is my solution. If I redraw my axis real quick, my X, Y, and Z axis, this point in space is saying I'm going 3 to the right, 0 up, and then 5 on the Z-axis. So this is sticking 5 units out of the page, is what's happening here. It is really hard to see 3-dimensional points in a 2-dimensional plane. So always make sure to kind of label that point. So let's try another one. Okay, so in this one I make my nice large brackets. My coefficients, I like to fill in the ones when I can. Notice this one isn't quite in the right form. So I'm just going to subtract the 2x to the other side. And I'm going to get rid of that equation. Okay? So they have to be in the correct order, or else your equation won't, or your matrix won't work. Alright, so I have 1x, 1y, 1z. So there's 1, 1, 1, and a 13. Here I don't have any x's. I have 1y. I have negative 1z and a 3. Here I have negative 2 x's. I don't have any y's, so I fill in a 0. I have 1z and a 0 here. So there's my matrix. So now I want to go into reduced row echelon form. So I go into my Desmos. Okay, I can hit enter and it'll make another line. So I don't have to clear everything out. I'm going to hit new matrix. See, this one calls it B instead of A. I'm going to add my columns in my row so that I have the correct size. Type in my values. Ooh, I was missing my tab key there. Let's type in my values. I'm going to double check to make sure I typed it in correctly. And then I click outside the matrix. And then to get it in reduced row echelon form, hit RREF and type the letter of the matrix that you want here. So notice I'm using B because that's the B matrix. And then here is our reduced row echelon form. And so I'm going to write my solution as an ordered triplet. 2, 7, 4. And this is my solution. 2 to the right, 7 up, and 4 out of the screen. Alright, and just one more just to drive in the point. So my first row, I have 1x, negative 1y, 1z, and a 5. Here I have 4 x's. I don't have any y's. I have negative 1z and a 3. And on this one, I don't have any x's, so put a 0. 1y. I don't have any z's, and then I have a negative 1 here. Alright, we go back to our calculator. I hit New Matrix, add my rows and columns. Okay, and then I click outside of my matrix, make sure that we typed it in correctly. Hit RREF, choose the letter of the matrix that I have, and here is my solution set. Now, here's something to notice. Do you see how in our equation we have y equals negative 1? Look, if I look at my y row, right, because there's a 1 where the y is, there's my negative 1. Okay, so if you have a situation where they automatically give you a variable, you want to make sure to always check for that. So my solution is at 1.4, negative 1, 2.6. Now real quick, I want to talk about a couple of special cases with matrices. I didn't plan very good space here, so I'm just going to erase this part. There we go. Now sometimes we might have a system of equations where the lines overlap. Right, so here's my drawing. I might have 3 lines that just happen to overlap like this. They're all the same line, but they might be multiplied by something. So I want to tell you how to find that. In a case like this where they overlap, there's an infinite number of solutions, because every point on the line, like here, or here, or here, every point is the same. So the way that looks in a matrix is when you have your reduced row echelon form, your first 2 rows will look normal, right? You'll have 1, 0, 0 and a number, and 0, 1, 0 and a number. But your third row will have all zeros like this. So if your entire bottom row is all zeros, there's no 1 here, there are infinitely many solutions. And the reason why for that, if I go to write this out as an equation again, I'd have 0x plus 0y plus 0z equals 0. And if I simplify this, right, 0 times anything is 0. So this equation is 0 equals 0, which is true. Now the other special case is when you have 3 lines in space and they never intersect with each other. Okay? And here's what you'll see in your matrix. Okay, your first 2 lines will probably look normal. And then your third line will have all zeros on the left and then some kind of number here at the right. So if you have a situation like this, there is no real solution. And the reason for that is if I write it as an equation, if I have 0x plus 0y plus 0z equals some kind of number that's not 0. So say it's like a 7 or something like that. Okay, all these zeros turns into a 0, so it says 0 equals 7. And that's not true, right? 0 doesn't equal 7. And so, because it's producing something that's false, that's why it would be no real solution. Okay, so just be aware of those two special cases. Alrighty guys, until next time.